20, 55. Find the minimum and maximum number of nodes between critical points. Let me first explain the problem because the descriptions is really long, but it's also really easy to understand. So the critical point in a linked list is defined as either a local maximum or local minimum. Yeah, so let me just use maybe this example. Yeah, because this is definitely a better example. So we're going to check the local minimum and the local maximum. So for this 3 is less than 5, but this 3 is more than 1. It is not like that. But for this 1, it is the local minimum because 1 is less than 3 and 1 is less than 2. So 1 is an answer. And what about this 2? 2 is not. And what about 5? 5 is an answer because it is a local maximum. 5 is more than 2 and 5 is more than 1. And this 1 is a local minimum. Yeah. So what are we gonna do? We just need to take the we just need to put all those numbers inside an array. Yeah, because for the array we have the index, and then we're gonna put the index in another array. And for this array, we can check the minimum distance and the maximum distance of the critical points. Yeah. So this is gonna be the maximum distance, and this is gonna be the minimum distance. And yeah, if we have the minimum distance and maximum distance, so we're gonna return the minimum distance and maximum distance. If we don't have it, so we're going to return a -1 and -1, like this example. So this means for the final answer array, so for this array, I'm going to call it answer array because inside it's going to be the index like I and Z. So if the answer array, the length of the answer array is less than and equal to 1, that means it is not possible, so we're going to return a -1 and -1. So if it is more than 1, definitely we have the local minimum and the local maximum, and we can check the final result. Yeah. So, yeah, I think that's for it. And how to calculate the local minima? So we have a few values inside the array. We just need to pairwise all the values, and we're going to use this z minus this I, so it's going to be the local minima. And what about the local maximum? We just need to use the maximum value, maybe this value, and the minimum value maybe here. So this is going to be n minus 1. And this is going to be 0, index 0. So we're going to use the value from the last value minus the first value, because inside it is always index. So we're going to use the last index minus the first index, so we're going to get the maximum value. So finally, we just need to return the minimum and maximum. Yeah. I think the idea is really easy to understand. I'm going to prepare a result array, and I'm going to loop through the head of the linked list. So for the result, I'm going to pad the head.value, and the head is going to be equal to head.next. Now I have the result array. So what I'm going to do, I'm going to have a tag, and I'm going to put the index inside the answer array. And how to check that? So for I in range, from index 1 to length of the result array -1, and then I can check. Yeah. So if result I more than result I -1, and result I more than result I plus 1. Yeah, because I'm gonna check the local maxima, or I'm gonna check the local minima. Let me just copy it. So from here, we're gonna check the local minima. So I just needed to, yeah, change the more than to less than, and here more than to less than. Yeah, so if I meet the condition for the local minimum or local minimum, maximum, it means a critical point, so I can put it inside the answer. So inside the answer, it's going to be the index. So I'm going to append the index. Yeah, now I can return the final result, but I need to have a check. So if the length of the answers is less than or equal to 1, so it means it is not possible. So I'm going to return a -1 and a -1. Otherwise, I can calculate the minimum and the maximum. Yeah. So let me first calculate the maximum value. And this is going to be easy. It is going to be just the answer -1 and minus, yeah, because we are checking the distance. So the distance inside the answer, it is the index. So we're going to use the answer -1 minus answer 0. So this is going to be the maximum distance. Now we're going to calculate the minimum distance. So it's going to be the minimum of b minus a. So for ab in pairwise, so we're going to pairwise the answer. So inside the answer, we're going to pairwise it. Yeah, and this AB is going to be the place of the index, and I'm going to use the b minus a. And from here, I'm going to check the minimum distance. Yeah, this is why we're gonna use Python, because everything is just so easy. We don't need to use so many lines of code. Just one line of code is enough to check the minimum value. Yeah. Finally, we just need to return the minimum and maximum. Now let me just submit it. As you can see, it works. And now let me just submit all the testing cases. As you can see, it works and it's pretty fast. And the time complexity is just ON. Actually, we just need to look through the linked list and then loop through the array, but no matter how we did that, the final time complexity is ON. It is linear time, and n is the number of nodes. It is 10 to the power 5. I think that's for it. Thank you for watching. See you next time.